All right, so this is a continuation of the last video. So there's actually 3 videos of examples in this section to help you along with your homework. So again, when we verify trigonometric identities, we're only going to work with one side, and we usually change the more complicated side into the less complicated side. But in this case, I'm really not all that sure what's more or less complicated. So let's just go ahead and start with the left-hand side. I'm going to start with this side. I'm going to transform this one into the other side. So let's go ahead and square this. And I know that a minus b squared is a squared minus 2ab plus b squared. So I'm going to go ahead and apply that formula for squaring a binomial that I learned in chapter 5. So I'm going to get secant squared of alpha minus 2 secant of alpha tangent of alpha plus tangent squared alpha. Okay, so that really makes things look a lot complicated. So I'm going to go ahead and change everything to sine and cosine and see what happens here. So when I change secant squared to sine and cosine, I get 1 over cosine squared of alpha minus 2 times 1 over cosine of alpha. Tangent is sine of alpha over cosine of alpha. And then I'm going to get sine squared alpha over cosine squared alpha. And I want you to notice here that I have a cosine squared and a cosine squared, and if I actually multiply this, I get a cosine squared. So I have three items or 3 rational expressions that have cosine squared in their denominators. So I'm going to go ahead and square or multiply that middle term so I can see exactly what I have. And then, because they all have the same denominator, I'm going to go ahead and combine it into one fraction. So 1 minus sine of alpha plus sine squared alpha all over cosine squared alpha. All right, so let's take a look at the numerator. This looks like a trinomial that can be factored. It looks like a minus 2b plus b squared. Maybe there's an a in here because a is 1 in this case. Really looks like I can factor this, so I'm going to go ahead and factor it. So when I factor this, I know it's going to be 1 minus sine of alpha squared. And then I notice that, geez, I have 1 sine of alpha in the numerator over here, right? If I could just change cosine of alpha into something that might be able to be factorable, then maybe I could get rid of that 1 minus sine alpha. So I'm going to use one of the alternative forms that I found in my Pythagorean identity, and I'm going to set cosine squared alpha to 1 minus sine squared alpha, which I know factors. This is a plus b and a minus b. So now I have 1 minus sine of alpha, right? This is going to be a squared minus b squared, which factors into a plus b and a minus b. All right. So now I notice that I have one of my 1 minus sine of alphas that reduces out, and I can write this, which is exactly what we needed to get on the left-hand side. And this was kind of a very long proof. All right. So that is how you would do this proof if you wanted to start on the left-hand side, but nobody says that we have to start on the left-hand side. Maybe it would have been easier to start on the right-hand side. So what would it look like if I was going to start on the right-hand side? Hopefully it'll be easier. I don't know. Okay. So we used a bunch of the hints found on page 197. We did a lot of factoring, multiplying out, working through indicated operations, right? One of the indicated operations that we worked through here was actually squaring, and then actually adding and subtracting by finding common denominators. So now let's go ahead and work on the left-hand side. One of the really nice hints that they tell us is that we can multiply by the conjugate. All right, so you guys remember conjugates. If I have a plus b, what's the conjugate? It's a minus b. If I have a minus b, the conjugate is a plus b. And when we multiply conjugates, what do we get? If I multiply these, I get a squared minus b squared, which is really nice. Okay, and you'll see why in just a second. So conjugates, I do a lot of multiplying by conjugates in my proofs. It simplifies things and it helps me to do my verification. All right, so let's take a look at this. Why would I use a conjugate? Well, I have a binomial in the denominator, and on the other side, if you notice, I really don't have a binomial. All right, I mean, I really don't have a binomial in either of these denominators, because this is really 1 over cosine of alpha, and this is sine of alpha over cosine of alpha. So somehow if I could get this to be cosine of alpha in the denominator, that would be really nice. All right, so while I'm not working this left-hand side, we always have to keep alternative forms of this left-hand side in our mind so that maybe we can get there. Okay, so when I see a binomial in my denominator, my first thought is let's multiply by the conjugate of that binomial. Okay, so when I multiply by the conjugate, I get 1 minus sine of alpha squared over, when I actually do this multiplication in the denominator, I get 1 minus sine squared alpha. And that is one of my alternative forms for a Pythagorean identity. So I get here 1 minus sine of alpha squared, and this is going to be cosine squared alpha. I can replace this bottom with. Well, if I really think about this, if I square this, right, they both have the same denominator, so I could look at this. That is exactly what I have here. So I think what I really need to do is I need to change this just slightly. 1 minus sine of alpha squared. And now I'm going to change it to look like this instead. All right. So now, because they are both in squareds, I can actually write it like this: sine alpha over cosine alpha squared. And now I can split my fraction up into 1 over cosine of alpha minus sine of alpha over cosine of alpha squared. And when I reduce these fractions, I get secant of alpha minus tangent of alpha squared. So I can work this proof both ways, right? I'm manipulating only one side and transforming it to look like the other side. Okay, all right, so this is my last example here. Now's when you should go off and try some of your homework problems.